In this video, I want to show you how to extract kinematic information from a force versus displacement graph. And the approach is I'm going to actually calculate the work done. We can get that from a force versus displacement graph. So let's begin. Let's start over here. So we are at 3.0 meters. Okay, first part of the question. Now, how do you calculate work? So we know that work is equal to force times distance, or work is equal to the mass of the object times its acceleration through a distance, or we know that work equals area under a F versus D curve. So that's some information that we will rely upon. So let's use this graph here. Let's indicate the 3 meter mark. That would be right here. And let's call this area 1 at 3 meters. Okay, let's begin. We have work is equal to the area 1. Area 1 is going to be equal to, it's a triangle, so 1/2 base times height, 1/2 3 times 3, which is going to work out to 4.5 joules. So I'll call that work 1. Okay, good, done. Now what I could do is I can use that work and use this formula here with the acceleration to figure out the acceleration, because out of these two formulas, D is a kinematic variable and A is a kinematic variable. So I already have D, so it would make sense that I would use this formula. So work is going to be equal to MAD. Work is 4.5. The mass is given as 5 kilograms. And the distance is 3. So 5 times 3 is 15. 4.5 divided by 15, A is equal to 0.30 meters per second squared. Okay, so I know the average acceleration across this line. It's the average. It's not what the maximum is. It's because the force is changing. So this represents the average acceleration in this interval, the distance interval. Okay, so we're going to divide this for neatness. Let's list the kinematic variables: x, t, v naught, v, and a. X is given as 3.0 meters. I don't know the time. We are starting from rest. I want to find out the final velocity. That's my question. And a is equal to 0.30 meters per second squared. So what I could do is I can use the VF squared equation. So V squared is equal to V naught squared plus 2AX. That's equal to 0. So V is going to be equal to the square root of 2 times 0.30 times the distance 3. So V works out to 1.3 meters per second. So there's the first answer. So in the first 3 meters, the object achieves a velocity of 1.3 meters per second. Okay. So what happens in the by the time it gets to the 6 meter mark? That would be over here. Okay, we can use the same approach, but this object right here is neither a square, nor it's a triangle, nor is it a trapezoid. Now I can divide this into all kinds of shapes, but the simplest thing for me to do is to divide this into a square and a trapezoid. Okay, so I'm going to call this A2 and call this A3. And what I'm going to do is I'm going to consider this entire area, A1, A2, A3, in calculating the work. So this would be at 6.0 meters. Okay, and I'm going to take the same approach. Work is going to be equal to the area total, right? And I already have A1. A1 is equal to 4.5. So let's calculate A2 and A3. So work is going to be equal to, here I'll write A1 plus A2 plus A3 to make it clear to you. A1 is 4.5 plus, let's use square brackets here, A2. A2 would just be base times height. So 1, 2, 3 times 2. So 3 times 2. And A3, let's do that one. That's a trapezoid. So this trapezoid has a height of 1, and the top of the trapezoid is 2, and the bottom is 3. So that would be 2 plus 3 divided by 2 times 1. So what do we have? We have 4.5 plus 6 plus 2 plus 2, that's 5. 5 divided by 2, so that's 2.5. So that works out to 13. 13 is the area, so that means 13 joules. So the work is going to be equal to 13 joules. Okay, so now we solve the problem just like we did previously. X, T, V naught, V, and A. X this time is 6 meters, 6.0. We don't know T. We're starting from 0. What I did is I'm solving the entire area, or the entire work from 0 position to 6. What I could have done is I could have used this speed here, but that seems a lot more complicated. So I just took the whole picture. So this is equal to 0. That's what we want to figure out. And oh, I think I'm going too fast here. This I don't know yet, so let's figure that out over here. I need to know my A. So I made a mistake, got carried away, but you see that if you organize yourself, you discover your mistakes. So I'm going to backtrack. So W is equal to MAD. This is 13. Mass is still 5. A, and now the distance or displacement is 6. So it'd be 13 divided by 30. So A, this time it works out to 0.43. 0.43 meters per second squared. Good. Saved myself. 43 meters per second squared. Okay, so now the V squared is equal to V naught squared plus 2AD. V is equal to, this is 0, of course, square root of 2 times 0.43 times a distance of 6. And crunch those in your calculator and you get 2.3 meters per second. Okay, that makes sense. It's going faster. The reason is here you have an average acceleration which probably occurs somewhere over here, and you reach a speed of 1.3, but then you have a continuous force of 3, and that's going to pick up the speed of the object, even though your force decreases here. This part here is very significant. That's what's going to increase the speed of the object.